For the third lesson this week, we'll be talking about the Unix operating system. The Unix command line and the utility commands it offers is one of our core tools in any data science project. Here, we give you a basic introduction to Unix-based operating systems before we utilize them in the context of upcoming lectures and exercises. If you're already experienced with a Unix-based command line, you may now skip this lesson and jump ahead. For the ones who are still here, at the end of this video, you will be able to explain what Unix is, understand files and processes, visualize the Unix directory structure, and start a Unix terminal and type your first command. Let's start with what is Unix and why it is important. You might be surprised to learn that most operating systems today are built on top of Unix, pretty much all the operating systems except for the ones that are based on the Windows operating system. Various Linux distributions, Mac OS X, iOS, and Android are just a few popular ones today. Here, we see a family tree of Unix-based operating systems. This figure alone shows the impact of Unix. Needless to say, this makes Unix widely adopted in industry. In fact, the back end of many data and compute systems, including industry giants like Facebook and Google, utilize Unix. As an operating system, Unix provides a very powerful development environment built upon composability of small utility programs that do one thing very well. We call these programs commands. Users can build their own commands and programs using these commands, and some programming syntax, or shortly, scripting. Unix is definitely an expected skill for most programming jobs, but why is it relevant to us as data scientists? In addition to being a powerful operating system, Unix provides commands for data search, subsetting, and transformation. Effective use of these commands can help with quick manipulation and analysis of data through the command line. This can be very helpful, especially during exploratory analysis and data preparation. Unix even provides quick ways to chain commands together as a simple pipeline. In addition, many data science tools come with a command line interface, which requires interaction with the command line and execute through the Unix shell. You might find it easier to engage with other command line tools and applications after having some experience with the Unix command line. So let's get started. We'll start by looking at the three main parts of the Unix operating system, namely the kernel, the shell, and programs. The Unix shell is the interface between the user and the kernel, which acts as a command line interpreter for Unix. Simply, it allows Unix commands and other user-developed programs to be executed by the kernel. For example, in this shell, ls is a Unix command for listing files. It will be interpreted by the shell and executed when the user enters return. The Unix shell starts automatically every time a user logs in to a Unix-like system. It accepts commands and makes system calls for those commands to be executed. It also provides a programming or shell scripting interface with the shell environment. To summarize, in Unix, commands are programs that are executed by the shell. Each time the shell receives a command from the user, it communicates to the command to the kernel, which in turn creates a process with a unique identifier to run it. An important feature of Unix is that everything is represented by a process or a file, even the hard drive volumes. This is why there is no concept of named drives like Windows. A process is an executing program identified by a unique process identifier that we will often refer to as a PID. Files are collections of data and they're organized in a directory structure. Users and running processes create these files. Directories actually are just special files which contain other files. Files are organized in a hierarchical structure that looks like an upside-down tree with a root. To reach and work with each file, we go through what we call paths within this tree structure. Paths separate each node of the tree that we are touching by a slash character. We can start by the root and go through each directory separated by a slash to reach each file. This is called an absolute path. Here, we see an example absolute path for foo.txt, namely /users/altintas/foo.txt. If I use this absolute path, I can reach foo.txt anywhere throughout my Unix-based system. Another way to reach foo.txt is using relative paths whenever we can. If I'm already in my home directory is altintas under users, and it's represented by green here. I can reach foo.txt under this directory directly without listing other directory names. This is called a relative path, as it's relative to the directory we are operating under. We refer to the directory we are operating under as the working directory. So, altintas as the working directory represented in green, I can say foo.txt or /foo.txt to reach foo.txt. Here, dot refers to the working directory. Now let's say I'm in the working directory Python for data science. Python for data science is shown in yellow here, and I'm in it as the working directory. I'm trying to access foo.txt under altintas. I can choose to change my working directory to altintas and use the relative path that we have used before, or I can use the absolute path for foo.txt. However, there's a simpler way to access foo.txt in this situation that Unix offers. We will take advantage of the ..dot directory, which refers to our parent directory. Each Unix directory has a special utility that refers to the parent directory of that directory. For Python for data science, that directory is altintas. The parent directory is represented by double dots, and we reach foo.txt from Python for data science using the parent directory by saying ../foo.txt. So we went through absolute paths and relative paths. Now I would like to show you another important shortcut in the Unix system, the tilde character. Any directory under users, like altintas, refers to a specific user's home directory. For that user, tilde refers to that home directory. I can reach anything under my home directory using the tilde character, like tilde/foo.txt or tilde altintas/foo.txt. Here's a word of caution when you work with relative paths. You need to check which directory you're in, or when you use a relative path within a running program, which directory that program will run in. Otherwise, you will have errors related to the paths. A good Unix command to check the directory is called pwd. It stands for print working directory. Let's start a Unix shell and review what we learned.